Okay, here we are at topic 1.4, surface area of right pyramids and right cones. A right pyramid is a three-dimensional object that has triangular faces, side faces, and a base that's a polygon. The shape of the base determines the name of the pyramid. For example, if it's a square base, it's called a square pyramid. If it's a rectangular base, it's called a rectangular pyramid. Now the triangular faces meet at a point called the apex. That's the very tip or the top of the pyramid. The height of the pyramid is the perpendicular distance from the apex to the center of the base. That's different than the slant height, which is the distance from the apex to the perpendicular bisector of the base on the side of the face. Think of it down as like a slide. So when the base of a right pyramid is a rectangular polygon, the triangular faces are all congruent. Then the slant height of the right pyramid is the height of the triangular face. There's the slant height there. You'll notice that the slant height goes down the side, the slant height goes down the side, the slant height in the third one goes down the side, but the actual height in the last one goes from the apex to the middle of the base. Now on the bottom it says the surface area of a right pyramid is going to be the sum of the areas of the triangular faces and the base, just added together. And let's do an example. So here we have a right square pyramid that has a slant height of 10 centimeters and a base that has a side length of 8 centimeters. And since it's a square pyramid, all four sides or all four lateral faces are going to be exactly the same. Now we could draw a net of this and lay it out flat. And this net shows the faces and the base of the pyramid. Well, let's start with the base. We can say that the area of the base is going to be side times side, or s squared. And that's going to be 8 times 8, which is 64. Now we can look at the area of one of the triangular faces. Well, that's a triangle, so it's going to be base times height divided by 2. And now we can say that that's got to be a base of 8 and a height of 10 divided by 2. 8 times 10 is 80 divided by 2, which is 40. So here we go. The base is going to be 64 for an area. One of the faces is 40. Each of the faces is 40. So now we just have to add up those numbers. We can say that the surface area is the area of the base plus the area of the four triangular faces, which is going to be 64 plus 4 times 40, or 224 square centimeters. And that'll give us the entire yellow section all shaded in. Moving on to example 1. Determine the surface area of a regular tetrahedron given its slant height. Well, remember a tetrahedron. It's called a triangular pyramid, and a regular tetrahedron has 4 congruent or equilateral triangular faces. Here we have a side length of 9 and a height, or slant height, of 7.8 centimeters. So what we're going to do is we're going to say it as a surface area of 4 times the area of one of the faces, and that's going to be base times height divided by 2, which is 9 for the base. The height is 7.8 divided by 2. Now when I say height, I'm referring to the height of the triangular face, not the height of the pyramid. So that'll give us the area of one face of 35.1. So that tells us that the surface area is going to have an area of 4 times 1, 4 times 35.1, or a surface area of approximately 140 square centimeters. Your job is to check your understanding on your own. In example 2, we're going to determine the surface area of a right rectangular pyramid. Now this is going to be a little trickier in this case because they're going to give us the height of the pyramid, not the slant height. We're going to have to work that out for ourselves. So here we go. First of all, we're going to draw a picture, and you're going to notice that the sides are 10 by 8. Now it's kind of tricky to figure out the area of one of the faces, because when we look at the first one, we're going to say the base, first of all, is 8 by 10, or 80. The area of the big triangular face, which is going to have a base of 10 and a slant height of S, that means that the side of the triangle that we're going to use there is going to give us the blue. This is going to be the blue triangle that we're figuring out now. And notice that the blue triangle is going to have a base of 4, which is halfway across the 8 side, and that means that the height is going to be 16. There we go. It's going to be blue. Now when we keep going, the actual height is going to be 16, so that means we have to figure out the slant height. So you're going to have to use Pythagorean theorem, a squared plus b squared is equal to c squared. Plugging in 4 squared plus 16 squared is equal to c squared. 16 plus 256 is equal to c squared. C squared is 272. Taking the square root of both sides, you're going to find c is approximately 16.49. Now I can figure out the area of that face, because the base is going to be 10, and the slant height now, we've just figured it out to be 16.49, so it's going to give me the area of the front face, the face that's facing us, of 82.45. Now we're going to do the same thing with the other side. We're going to find the area of the smaller triangular side. This time we have a base of 8 and a height of 16, or slant height. So we're going to figure out now, this one is going to have 5, and the height is going to be 16, and that's going to be S. So we have to solve this Pythagorean theorem to figure out the slant height of the red triangle, which gives us the slant height of our smaller triangular face. And that'll be 5 squared plus 16 squared, and it'll be the square root of 281, and c is equal to 16.76. So the area of that face is 65.96. So now we're ready to figure out the total surface area. So here we go. Using those three figures, the total surface area is going to be the area of the base, which is 80, plus 2 times the larger side faces, which are going to be 82.45, plus 2 of the smaller side faces, which are going to be 2 times 65.96. And the total thing is going to be 376.82, or 377 square feet. So here we go. In summary, we can say that the surface area of any right pyramid can be found by finding the area of the base plus the area of all the triangular side faces. We say that the surface area is the area of the base plus the area of the side faces. Now, let's look at the surface area of right circular cones. Now, a right circular cone, there's a picture of it there. This is a three-dimensional object. It's in three-dimensional space that has a circular base and a curved surface. The height of the cone is the perpendicular distance from the apex to the base. The slant height of the cone is the shortest distance on the curved surface between the apex and a point on the circumference of the base. So again, down the side. If we look at the cone that's upside down, we say that the base, that part, has an area of pi r squared. Now the side surface of a cone has an area, or a lateral face, that has an area of pi rs. So putting those two together gives us the total surface area of a cone of pi r squared for the base plus pi rs for the side. You may be asked to calculate just the base or just the side on an assignment or an exam. In example 3, we're determining the surface area of a right cone. So a right cone has a base radius of 2 feet and a height of 7 feet. Calculate the surface area of this cone to the nearest foot. So here we have a cone. The radius is going to be 2 feet. The height is going to be 7 feet. So to figure out the surface area, we need the slant height. And since we have 7 and 2 and x, we can say 2 squared plus 7 squared has to be x squared, because x is the hypotenuse. And 4 plus 49 is going to give me c squared is 53. Take the square root of both sides, and c is root 53, or 7.28 approximately. Now we can say that the slant height is 7.28. And we can calculate our surface area, pi r squared plus pi rs. Make sure you use the pi button on your TI-84 or 83 calculator. So the surface area is written as pi times 2 squared plus pi times 2 times the slant height of 7.28. And when you calculate that in your calculator, you're going to get 12.57 or plus 45.74, which is going to be 58.3 or approximately 58 square feet. In our last example, we're going to do determining the measure of an unknown measurement. Well, here we have the lateral cone. Area of a cone is 220 square centimeters. The diameter of the cone is 10. We want to figure out what the height of the cone is to the nearest tenth of a centimeter. So here we have our picture. We have the diameter being 10. We want to figure out h. So we can say the surface area is pi r squared plus pi rs, but we're only given the lateral surface, which is pi rs. We don't need the pi r squared. We're not told that part. So since pi rs is equal to 220, that's the pi rs part, that's the pi r squared part, we don't have the pi r squared part. So 220 is going to be pi rs, which is pi times the radius of 5, because remember the radius is half the diameter. So if I divide both sides by 5 times pi, you can cancel the 5 and the pi on the right side, and 220 divided by 5 pi is 14.0056. Now that's going to give me my slant height. I can take my slant height and Pythagorean theorem using the triangle of the yellow. I want to find h, knowing that 14.0056 down the side, or 14, and 5 gives me a squared plus b squared equals c squared. Notice the hypotenuse is 14, so I've got to make sure I put them in the right spot. 5 squared plus h squared is going to be 14 squared. And that'll tell me, by subtracting 5 squared from both sides, that h squared is 17.1578. And if I take the square root of both sides, I'm going to get a height of approximately 13.1 centimeters. That takes us to the end of our lesson of 1.4.